So let me ask quick, do you guys have any questions? Anything you guys want to go over? The homework or anything? I made my last announcement, so you guys can check that out on Brightspace. Mhm. What about you, man? You have any questions you want to go over or anything? Yeah. Chevy Chev, yeah, yeah, yeah. Yeah. We could do an example from that. Yeah. So there's two ways that the question could be posed, right? They could either give you what K is, or they could not give you what K is, right? So I'm gonna go the long way and show you what happens when you don't get K. But the answer for Chebyshev theorem is always this: mu minus K sigma, right? To let me write to mu plus K sigma, right? So that's always going to be the answer. Now they're going to give you whatever mu is, right? They're just going to tell you what it is, right? Let's just say for fun that it's 20. I'm just making it up, right? And they're going to give you what sigma is. Let's just say for fun that it's 2. Again, I'm just making it up, right? But they might not give you what K is. So if they don't give you K, there's a formula to find out K. It's percentage is equal to 1 minus 1 over K squared. Just like that, right? So in this story, like this scenario, they're giving you a percentage, right? Like let's say that they want, I don't know, 95% of the data. So you just write in the 95 and you just solve for K, and that's it, right? So with this one, go ahead. Yeah, we need K for this formula to work, you know? We already know what the mean and the standard deviation is, right? That's easy, just plug that in. But we just need to figure out what K is, right? So let's rewrite this. This would be like 95 over 100 is equal to 1 minus 1 over K squared. You could totally use a calculator for this. You don't have to go through all this work, right? But I'm going to go through it and show you, right? So I'm going to subtract 1 from over here. What I do to one side, I do to the other. So I have what? 95 over 100 minus 1 is equal to negative 1 over K squared. Now that's a 1, right? So, and think of 1 as being like 1 over 1. So in order for me to subtract, I got to have the same denominator, right? So to make the 1 into 100, I have to multiply it by 100, right? What I do to the bottom, do to the top. All right. So 95 minus 100, we know is negative 5 over 100. Very good. And that's going to be equal to negative 1 over K squared, right? You could divide by negative 1 on both sides. That's going to kill the negatives. So that just gives you 5 over 100 is equal to 1 over K squared, right? You can flip them, right? What you do to one side, you do to the other. So that's going to give you 100 over 5 is equal to K squared over 1, which is just regular K squared, right? And then to get rid of the square, you know you're going to square root it. And what you do to one side, you do to the other, right? So now I have K is equal to square root 100 over square root 5. Square root of 100 is, what's that? 10, right? So this becomes 10 over square root 5. You know I can't have radicals in my denominator, so we have to rationalize and multiply by square root 5 over square root 5. So this is my answer, 10 square root 5 over 5. But we can go a step further, right? 5 goes into 5 once, 5 goes into 10 two times. So 2 square root 5. That's K, right? So going back up to the top, what's my answer? Replace the mean with mu, right? So it's going to be 20 minus the 2 square root 5 times the standard deviation, which is 2, right? 2, the same thing on the other side, but with a plus sign. 20 plus 2 square root 5 times 2. That's it. Oh, 2. Like like the word 2. That's what it is, 2. Like it's the word 2. Or I mean, if you don't like that, I could put a hyphen. Does that make more sense? It's a range, right? I'm going from this smaller number to that bigger number, right? So that's all that is. You could do the math on it if you want. This is like what, 4 square root 5, and then 220 plus 4 square root 5, and then that'll be your answer. Right? So that's how you do it in a nutshell, right? Now, let's say that they gave you K. That's even easier. You just go straight to this and just plug it in, right? But if they don't give you K, that's the longer process where you have to find K because they're going to give you some percentage, right? A reverse question they could ask you is they could give you the range and then something they could give you the range and then ask you like, okay, what's the percentage that this corresponds to, right? If they do that, you just have to solve for K and then you just plug it into the formula and do the reverse, right? So like let's say that K was 3. I don't know, I'm just making it up, right? Like you use the range and you found that K was 3, right? You just plug it in the formula, 1 minus 1 over K squared should become 1 minus 1 over 3 squared. And then just finish it. This is 1 minus 1 over 9. Yeah. Right. Yeah. So yeah, and then this one would just be like 8 over 9, and that's it. Mhm. So yeah, one scenario you don't know what K is, another scenario you know what K is. Yeah. But you can play with it in the homework. You'll have multiple questions like that. Yeah. Anybody else any questions? Yeah. So I just made this up. The question was about Chebyshev, like how to do that. Yeah. So I was just giving like two scenarios, like one where you know what K is and one where you don't know what K is. Mhm. But in the homework, you'll see some examples like that. You could practice it.
When is spring break in April first?
April 1st. Yeah. To April what? Okay. Yeah. I know it definitely starts April 1st. Oh, so you're saying that April 10 is class. Okay. Gosh. Yeah, that's what I thought. I thought it was till April 13.
Will they be working here? They will be operating here?
Probably not.
No.
Probably not. I'm gonna answer that question for you real quick. I'm gonna look it up right now.
But if you want them over, do homework, something,
Yeah.
it's campus. Great.
I'm over here looking at February. Wow. Um, yeah, April 1st, April 9. You're right. That's our spring break. So if you have class on Friday, then April 10 you go to class, all right? Or if you have class Saturday, Sunday, April 11, April 12 you go to class. Mhm. I'm gonna assume that Saturday, April 11th will be open for tutoring. All right. If you guys want to go. Probably April 10 it will be open as well. But I should have an update for you on that like next week. Yeah. Yeah, but just looking at the calendar, that's what the calendar says. All right, let's look at what we're looking at now. So we're going to be talking about an introduction to random variables and probability distributions. This is going to be really, really cool. All right. So, random variables, for our purpose, will say that a statistical experiment or observation is any process by which measurements are obtained. For instance, you might count the number of eggs in a robin's nest or measure daily rainfall in inches. It is common practice to use the letter X to represent the quantity or the quantitative result of an experiment or observation. As such, we call X a variable. All right. So let's talk about random variables. So a quantitative variable x is a random variable if the value that x takes on in a given experimental observation is a chance or random outcome. A discrete random variable can take on only a finite number of values or a countable number of values, right? Keyword there, countable, right? A continuous random variable can take on any of the countless number of values in a line interval. All right, fair enough. I'm gonna make this real nice and easy. This is like question one of your homework. Mad simple. All right. So the distinction between discrete and continuous random variables is important because of the different mathematical techniques associated with the two kinds of random variables. In most of the cases, we will consider a discrete random variable will be the result of a count. All right, that's keyword there, counts, right? Discrete counts. All right. The number of students in a statistics class is a discrete random variable. Values such as 15, 25, 50, and 250 are all possible. However, 25.5 students is not a possible value for the number of students, right? So whole numbers, not fractions. All right, that's discrete. Most of the continuous random variables we will see will occur as the result of a measurement on a continuous scale. For example, the air pressure in an automobile tire represents a continuous random variable. The air pressure could, in theory, take on any value from 0 pounds per square inch, psi, right, to the bursting pressure of the tire. So values such as 20.126 psi or 20.12678 psi and so forth are all possible. Mhm. All right. I want to just look at an example real quick before we move on from that. Go ahead.
Sorry.
Yeah.
That is my concern, but
Mm-hmm.
what happened with Santa Maria?
She's okay from what I understand. Yeah, she's healing. Yeah.
But she is
Yeah.
in your class, yeah, right?
Yeah.
Okay, cool.
Yeah.
Okay, she's very motivated. Like,
Mm-hmm.
okay, cool.
Some people could just be watching the recordings. you know?
Okay.
Yeah.
I thought she dropped this semester.
Mm-mm.
Okay.
Mm. But speaking of which, you guys did get y'all midterm grades if y'all want to check it out. I have no idea where you go to check it out. I'm not even gonna lie to you. It was a brand new website that I was just introduced to like last week. So I'm new to it as how you guys are. You know, back in the day, we had this old website. It was called OSIS, so we could go in there and we could see all our midterm grades and stuff like that. But they killed it on March 4th, right? So this new website replaced it. Don't know where it is. Don't know where to tell you to go and look for it. But
Look
if
for
you guys have a minute, reach out to your advisors, maybe send them an email and ask them where to go to look for it. Because they would know. I'm not sure.
the class.
Like to look for your midterm grades.
Oh,
Yeah, yeah. I'm sorry. It's not on Brightspace. It's another website altogether. Yeah, but it's a weird website. Like I don't know where to tell you to click to go to see it.
in
No,
words where you can
no.
360 navigate and you might.
I don't think it's in 360 Navigate. It's something completely different from all of them. Yeah. So what I would advise you to like reach out to your advisor and ask your advisor like where it is that you click to see it. You know, like it's done and it's been submitted. I just don't know where you look to it. When I was filling it out on the website, it said that it was being submitted to registrar.
Well,
I
do
don't know
you
if that
have
information
well,
helps you. But yeah. Because it's different from when I was here. You know, like we had OSIS, we just going OSIS to see everything, but now this is something brand new. Yeah. All right. So real quick, let's look at this example right here, right? The question is, which of the following random variables are discrete and which are continuous, right? So measuring the time it takes a student selected at random to register for the fall semester, right? So that sounds like it could be continuous, right? Like it might take you 5 minutes, but it might take you 36 minutes and 29 seconds, you know? Continuous, right? Counts, keyword, the number of bad checks drawn on upright bank on a day selected at random, right? As soon as you heard the word count, you already know that's discrete, right? So the number of bad checks can be only a whole number, such as 0, 1, 2, 3, and so on. So this is discrete. Measure the amount of gasoline needed to drive your car 200 miles, right? Jeez. Y'all seen them gas prices lately? OMG. Yeah, man. It's viral. Sorry, so we are measuring volume, which can assume any value. So this is a continuous random variable. Pick a random number of excuse me, pick a random sample of 50 registered voters in the district and find the number who voted in the last country election, right? Since this is a count, that's discrete. All right. Questions on this? You good? All right. Yeah, I should have fun on that homework question. It's only one, but it's cool. So now we're gonna expand on this idea just a little bit.
but I got a question. Okay,
Mhm.
that is not so watching the videos, watching the classes videos, so that doesn't affect the students. I mean, the attendance here, no, at all.
I mean,
If they really want,
it affects the attendance because they're not here, but it's like that doesn't mean that you can't learn.
no, no, exactly, yes,
Mhm.
it's true. But I mean, to be able to go, they don't fail,
It
no.
won't fail. Mhm.
Okay.
All right, so probability distribution of a discrete random variable. A random variable has a probability distribution whether it is discrete or continuous. Okay? A probability distribution is an assignment of probabilities to each distinct value of a discrete random variable or to each interval of values of a continuous random variable. All right. So let's talk about the features of probability distributions of a discrete random variable. So one, the probability distribution has a probability assigned to each distinct value of the random variable. And two, the sum of all the assigned probabilities must be one, right? So you guys remember that axiom for probability? All of the probabilities must be able to add up to one, right? If they don't add up to one, it's not valid, right? This is another homework assignment. All right. It's okay. Let's look at an example real quick. All right. So this is discrete probability distribution. Dr. Mendoza developed a test to measure boredom tolerance, right? He administered it to a group of 20,000 adults between the ages of 25 and 35. The possible scores were 0, 1, 2, 3, 4, 5, and 6. 6 indicating the highest tolerance for boredom, right? The test results from the group are shown in the table, as you can see. If a subject is chosen at random from this group, the probability that he or she will have a score of 3 is 6,000 out of 20,000 or 0.30. In a similar way, we can use relative frequencies to compute the probabilities of the other scores in the second table. All right. So let me explain this a little bit, right? So they have this test for boredom, right? They gave it to the like a survey. They gave it to the patients, right? They asked them to choose a score between 0 and 6, right? 6 being that they have the highest tolerance for boredom. 0 is like they're gone, they're super bored, right? So, what this mean, the way that this is broken down, right? Let's say for a score of 0, right? For a score of 0, 1,400 people out of the 20,000 said that they were super bored. Like they were they had no tolerance for boredom, right? For example, 6,000 people gave it a score of 3 out of the 20,000, right? Saying that, so they had like a medium tolerance for boredom, right? The way that you get these probability of P of X stuff here, right? In the second column, simply just take the number of subjects that gave it that score, 0, for example, which is 1,400, and divide it by the 20,000. And that's how you get the 0.07. The next one, same thing, 2,600, and you're dividing it by the 20,000. So on and so forth. All right. And that's how you get this column for probability of P of X. And when you add it all up, must add up to 1. Questions on this? Just giving y'all the information right now. We haven't like done a question yet. All right. But just to recap, right? How do we get the probability scores? We take the event and divide it by the total, right? Event divided by total. Okay. Now, just want to throw it back for a second, right? You guys remember around February, like early February, when we were talking about histograms, right? You can actually represent this in a histogram, right? Now, my drawing is not so pretty, so I just want to show you guys like a computerized version of it. Just because for some reason a computer could draw better than me. I don't know. I got to work on my drawing. Got to work on my drawing. Right? So here's a histogram of all our scores, right? On the side here, we have our probability of P of X, right? So as you can see, going back up to the table, our highest probability was 0.30. So remember, we need our axis, our y-axis to go up to at least 0.30. As you can see, it does right here. And then we have our scores, right? Our scores are what? 0 through 6. Now, what's different about this histogram versus the ones that we used to do before? Remember, we used to have the class boundaries, right? We used to go from the smaller boundary to the upper boundary, right? Over here, we don't do that. Over here, we actually go in the middle is the number that's on the score, right? So 0, 1, 2, etc., right? It's in the middle of each bar, but still it's a histogram because remember, there's no space in between the bars, right? The bars are on top of each other, right? And then the height of the bars is just whatever number this is. So the first one is 0 point, like this is the 0.07, for example, right? And this is our 0.30, etc. Right? Any questions on the histogram for this? I'm not gonna ask you for this, but it might help you in understanding like how everything is displayed, right? When you add up all of the bars together, right? All of their probabilities, they should add up to one, right? No problem. Okay. Let's talk some more about this. So these probability assignments make up the probability distribution. Notice that the scores are mutually exclusive. No one subject has two scores. So you can't be like super bored and semi bored at the same time, right? The sum of the probabilities of all of the scores is one. The graph of this distribution is simply a relative frequency histogram in which the height of the bars over the scores represent the probability of that score. Since each bar is 1 unit wide, the area of the bar over the score equals the height and thus represents the probability of that score. Since the sum of the probabilities is one, the area under the graph is also one, right? As noted. So the top-notch clothing company needs to hire someone with a score on the boredom tolerance test of 5 or 6 to operate the fabric press machine. Since the scores of 5 and 6 are mutually exclusive, the probability that someone in the group who took the boredom tolerance test made either a 5 or a 6 is just the sum, right? Remember, or keyword that means add, right? It's our addition keyword. So the probability of 5 or 6 is simply just the probability of 5 plus the probability of 6. Looking back at the table, you could literally just add those two numbers, the 5 and the 6, right? So 0.08 plus 0.02 gives you 0.10. That's it, right? Simple, simple stuff here. Talk a little bit about the alphabet. All right. So notice that to find the probability of 5 or 6, we could have simply just added the areas of the bars over the 5 and over the 6. 1 out of 10 of the groups who took the boredom tolerance test would qualify for the position of top-notch clothing. A probability distribution can be thought of as a relative frequency distribution based on a very large n, very large sample size. As such, it has a mean and a standard deviation. If we are referring to the probability distribution of a population, we use the Greek letters mu, right, for population mean, and sigma, right, for population standard deviation. When we see the Greek letters used, we know the information given is from the entire population rather than just a sample. If we have a sample probability distribution, we use X bar, right, for sample mean and S respectively for sample standard deviation. All right. Just wanted to recap that. No, you do not need to memorize that. It's all on your formula sheet. All right. This next part here is also on your formula sheet. If you're wondering where we are, we're in chapter 6 right now. You look at your formula sheet, we're in chapter 6. All right. Again, this is on your formula sheet. The mean and the standard deviation of a discrete population probability distribution are found by using these formulas. So mu, our population mean, is equal to the sum of x times p of x. This is called the expected value of x. So when you hear the words expected value, you think population mean mu. All right? Expected value, population mean mu. Sigma, right, is equal to the square root of the sum of x minus mu squared times p of x. Sigma is called the standard deviation of x, right? Our population standard deviation, all right? I'm going to show y'all how we find those in a minute. Where x is the value of the random variable, p of x is the probability of that variable, and the sum sigma is taken from all the values of the random variable. Note, mu is the population mean, and sigma is the underlying population standard deviation because the sum sigma is taken over all the values of a random variable, i.e., the entire sample space. All right. So the mean of a probability distribution is often called the expected value, remember that, right, of the distribution. This terminology reflects the idea that the mean represents a central point or cluster point for the entire distribution. Of course, the mean or expected value is an average value, and as such it need not be a point of sample space, right? The standard deviation often represents a measure of risk. A large standard deviation implies a greater likelihood that the random variable x is different from the expected value mu, right? So large standard deviation, more risky. Small standard deviation, more safe. Think of it like that. Mhm. All right, let's take a look at an example. So this is expected value and standard deviation. Are we influenced to buy a product by an ad we saw on TV? National Informational can't say that. Infomercial Marketing Association determined the number of times buyers of a product had watched a TV infomercial before purchasing the product. Here are the results, right? So the first column, excuse me, first row, sorry about that, is the number of times buyers saw the infomercial, which is 1, 2, 3, 4, or 5 times. And then the percentage of buyers that actually bought it is on the second row, right? So you have the 27%, 31%, etc. Right? Special note, the category was 5 or more, but we will treat we will be treated as 5 is this example. So right here, you see where the 5 and a star is, right? So these people, may have saw a commercial more than 5 times or at least 5 times, right? To get into this 15% category, right? Just to make it easy, easy math. So anyway, we could treat the information shown as an estimate of the probability distribution because the events are mutually exclusive and the sum of the percentages is 100%. So then it says to compute the mean and the standard deviation of the distribution. Okay. So let's get it. I'm gonna call the number of times buyers saw the information in infomercial, whatever, X. And then my percentage of buyers, I'm gonna call that P of X. Okay. So not really a fan of the whole horizontal thing, right? More of a vertical kind of person. So just gonna do that. 1, 2, 3, 4. 1 second. I'm missing one. 5. All right. There we go. And then I'm gonna call this P of X. And I'm just copying down the percentages here, right? So this is what, 27%, 31%, 18%, 9%, and 15%. All I was doing here is just copying. Very simple, just copying. All right. Now to find the mean, all right, let me just go down for a second. To find the mean, mu, or our expected value, what's the formula, right? It's the sum of x times p of x, right? It's the sum of x times p of x. So going back up to our table, I need a column called x times p of x, all right? And what goes in this column? For the first one, you're going to take the x number, which is 1. You're going to multiply it times a p of x, right? Which is 27%. So that's 0.27. When you multiply them in your calculator, what do you get? You get 0.27. So on and so forth, right? Next one, you're going to take the 2. You're going to multiply that by the 31, right? So 0.31. That's going to give you what? 0.62. So on and so forth. Questions on this?
Wouldn't have a divider there?
No divide, just multiply. Multiply straight across, right? First column by the second column. All right. You guys try. What's 3 times 0.18? Wait, 0.54? Okay. Now what about 4 times 0.09? What's that? 0.36. That sounds good. All right, last but not least, what's 5 times 0.15? 0.75. Questions on this? Mhm. So they asked us to find a mean and a standard deviation. All right. So to find the mean, I need this special column of x times p of x. And then all I have to do is add it up. So the mean, mu, is equal to the sum of x times p of x, which is literally just add up these numbers that you have right here. Like 0.27 plus 0.62 plus 0.54, etc. Just add them up. Tell me what you guys get. Some, yeah. So 2.53. That's my mean. That's what you said, right? 54. Okay. I trust you. Yeah, it's just adding, just add them up and that's it. Right? So that's our mean, right? But they also asked, give me the standard deviation, right? So we got to do a little bit more work on the same table, all right? So I'm just gonna close this off here. Just imagine that that's closed off that way, all right? The next thing you want to do x minus your mean, all right? Now, why am I saying that? Our standard deviation, sigma, is equal to the square root of, excuse me, 1 second, the square root of the sum of x minus our mean squared times p of x. That's our standard deviation formula right there, right? So the first thing I need to do is I need to subtract all the x's from the mean, right? So for example, number one is going to be, or the first one, excuse me, is going to be 1 minus the 2.54, which is going to give me a negative 1.54. Little subtraction, that's it. The next number is going to be what? 2 minus 2.54, which we know is just going to be 0.54. Negative, right? Sorry about that. Negative 0.54.
That's all right. So to operate it finally. So
Yeah, just
we
subtract.
got it.
Yeah, just subtract. So the next one is 3 minus 2.54. What's the answer to that? What's $3 minus $2.54? 46. Sounds good. Next, right? We're gonna have 4 minus 2.54. That should just give you a positive 2.54, right? Then we have 5 minus 2.54. That should give us what? Yeah. You have $4 and you subtract two. Wait. Yeah, you're right. It should be 1.54, right?
Why do they like?
No, 1.56, right? Yeah. No, 1.46. What am I talking about? Oh man. It's Monday. Yeah, yeah. Let me get some more coffee. Hold on. Yeah, man. Gotta take a couple more sips. A couple more sips, and we'll be good. All right. That's it for this column, right? I need to make another column. I'm gonna eventually run out of space here, so just bear with me 1 second. So next, I want to square all of these numbers, right? So for example, the first one will be the negative 1.54. All right. You're just gonna square it in your calculator. And that's it. The next one's gonna be like negative 0.54. You just square it. So give me the answers for this. By the way, you're squaring a negative number, so you should be getting out a positive answer. All right. And you just type it in the same way that I have it written up here, right? Open parentheses, whatever, blah, 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 close parentheses, squared. All right. And that's it. Thirty-seven, 5, 6, 1, 6. Okay. What's the next one? I'm sorry? No rounding. Yeah. 29916. Okay. What's the next one? Just make it easy. 2116. Okay. And the next one? Mhm. 1316, like this. Oh, I see what you mean. Hold on. Like that. Got you. So it'll be like multiply by itself like this. No, but y'all have calculators, so I'm trying to get through this quickly. So what's the last one? It's 2.46 squared. Perfect. All right. Now, last column, I promise. All right. For this column here, we want to take the previous answer that we got, which is the x minus mu squared. We want to multiply that times the p of x. All right. So, for example, the first one, I could do it from here, right? So the first one is going to be the 2.3716 times the 0.27. What's that answer? The next one's going to be the 0.2916 times the 0.31. Next one's going to be the 0.2116 times the 0.18. Then we're going to have the 2.1316 times the 0.09. Right. And last but not least, we'll have the 6.0516 times the 0.15. Right. So remember, P of X is all the numbers in this column, the 27%, 31%, all of that, right? You're multiplying your previous answer by all of those. So, okay, tell me the answer.
So, the first step is sum, the second step, subtract, the next step, multiply, and then
Mhm.
Uh,
For like each one, it's on top. All the headings over here. So the first two was just copying. That was nothing, right? The next one was multiply, right? You want to multiply this column by this column. Boom, 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 right? The next one was to take each one of the x's and subtract it from the mean. And the mean was the sum of all of these numbers. So boom, right? This next column, you're just squaring the previous answer to the second power, right? But this one, you're going to take that squared answer and you're going to multiply it by the p of x.
instead of,
Yeah. Yeah. So what's the answer to the first one? So I got 2.3716 times 0.27. What you guys got? Mhm. You said 643? Like 6.43? Oh, like that. So like 0.640322. Okay. What's the next one? 62. That's it? Oh, it's the percentage, this thing. Yeah, yeah, yeah. Hello. Yeah. Hey, how you doing, man? The reason why I just pulled it over like this because I was looking in this column, like right here, like hold on. You see, like this number here. This is what I was concentrating on when I was making that last column over here. Yeah. Uh-huh. So X, uh-huh. So X are these numbers, right? On the boredom scale. No, I'm on the boredom. I'm talking about boredom scale. No, this is the TV show thing, right? How many times you saw an ad, right? So X is the number of times that the viewer saw the ad. One, two, three, four, five or more, right? P of X is the percentage of people that actually bought the item, whatever it is, after seeing the ad, right? And then the rest of this, I'm literally just copying these from the formulas that are on the formula sheet, right? I'm just like, these are it right here for mean and standard deviation. I'm just doing it step by step so it looks really long, you know? But you just break it down, just plug it in and you're good to go. Mhm.
that's it.
Almost. I'm sorry. Copying this part? Yeah. Remember, this is on the formula sheet too, so you don't have to worry about it not being on the test and all that. It's right there next to you. Mhm. All right. So I'm just waiting for some numbers. So next one, 0.2916 times 0.31 is what? Good time to practice on the calculator. Mhm. Yeah. 0.90. Three, say it again? Okay, sounds good. Now 0.2116 times 0.18. What's that?
0.03888.
Like this? Okay. All right. 2.1316 times 0.09. What is that? 1918 what? 44. Last. 6.0516 times 0.15. What is that?
0.9774.
0.09774, like
No,
that?
9774. Just delete it
Delete the whole
after
thing?
0.99
0.99.
0774. So just one nine.
Seven.
0774.
Okay, like that. Okay. All right. Everybody got the same answers? I'm trusting y'all. All right. So look, your variance, let me keep this up here, right? Your variance, also known as sigma squared, is equal to the sum of x minus the mean squared times p of x. Literally add all these numbers together. Tell me what you get. All right? Just add straight down.
1.868433.
1.86.
80436.
Okay. Everybody else got that? What you got? 1.86884. Okay. Huh? Okay. That's fine. Should give you the same answer regardless. Just don't round it. Don't round off the numbers and then add them. Add straight. Add what you see there. And that's it. Anybody else did it? Can confirm which one of these two answers is right? You got the first one, the first answer? That's okay. So we gonna go with the first one? All right. All right. I mean, I could do this myself, but I want y'all to get practice on y'all calculators, you know? All right, so look, that's your variance. Variance is sigma squared, right? Remember that your standard deviation sigma is always the square root of your variance. So now in your calculator, you're going to square root that same number that you got right there. So the 1.8680439. You square root it, you get the answer. That's the answer to the whole question. All right. So do it for me. On your calculator, just press second square root. You're good to go. All right. Sure, sure. You want to see this part? Okay. So you're just square rooting this number on the bottom, in case you didn't get a chance to see. The 1.86800439. Hmm? There was no zero there. So it was 868,439. Okay. I'll take it. Whatever. I trust you. I don't know. They were saying there was no zero there, that it was just 1.868439. Oh, just square root it. Square root that answer. Yeah. Like this with the house. Square root. Yeah. And tell me what you get. Mhm. No, the joint is crazy. Yeah. Maybe that one. Yeah. What? You can open all of them for all I care. Huh? Oh, sorry. Is that Apple? You got to turn it sideways. Well, that's the sideways. So you type in a number first, the 1.8 whatever, then you just hit the square root button and it gives you the answer. So then that's it. 1.36676402, whatever. That's it. Yeah. That's the process. Questions on it? Anybody? Yeah. That's it. No, this is brand new. Because this is for discrete probability, right?
Yeah, oh,
Yeah, yeah.
she might say we didn't mean it before,
Yeah.
we didn't mean it instead of the
Yeah.
future.
It's the same conversation as before, but the question has changed a little bit. The formula is different. Yeah. It'll be there. Like you're gonna see these formulas there, these two. Discrete probability. Yeah.
And when we talk
Yeah.
about PX,
It's
27%.
these. No, no, no. It's given to you. Yeah, it's gonna be given to you. Yeah. So that's the way the question looks, and then you're looking for the mean and the standard deviation. So this would be an answer, and this would be an answer. Mhm. The other answer is the mean. When we did the x times p of x, that's the other answer. And that's it. Easy, right? There's a whole question on this for homework.
You
Yeah.
will be, or you will be.
Yeah. Not all of it, just as much as I could write. Yeah. But if you want, you could put all of it. Mhm. For me, if you have to round off, give me four decimal places, right? But to be honest with you, I really don't like rounding. Just copy and paste what you see. Mhm. Mhm. Okie dokie. Well, yeah, it's there. Oh yeah, it's there. The new homework, yeah, yeah. I might have accidentally posted this last week, but this is how you do it. So good news is we're right. I know my handwriting's a little rough, so here you go. This is what we should have got. This is the actual table right here. If you want, you can take a picture of it. Mhm. Leave that up for a minute. But we did get these answers, so we're good. Oh, I didn't mean to click that. It's rounded off, that's why. But it is the same though. In the end, it ended up being the same. So, that being said, all right, our population mean mu is equal to the sum of x times p of x, which is 2.54, right? And then to find the standard deviation, we take the square root of what we have in column 6, which is this part right here. And then we get the 1.37, exactly what we found. So perfect. All right. So, what does discrete probability distribution tell us, right? A discrete probability distribution tells us the complete sample space on which the distribution is based, the corresponding probabilities of each event in the sample space, and formulas tell us how to find the expected value mu and the standard deviation sigma of the distribution. All right. So we have seen probability distributions of discrete variables and the formulas to compute the mean and standard deviation of a discrete population probability distribution. Probability distributions of continuous random variables are similar, except that the probability assignments are made to intervals of values rather than to specific values of a random variable. And we will see an important example of a discrete probability distribution, the binomial distribution, in the next section. And one of the continuous probability distributions in chapter 7 is the normal distribution. All right. So, more goodness to come. That's it for today. All right. Any other questions y'all got? Y'all good? All right, come sign the formula sheet before you leave. May I take this down? Is anybody still copying? Hold it. All right, I'll hold it. No problem. Y'all know I'm only asking so it could download. That's why it takes a minute to download. All right. Don't really have no commercial breaks for you guys this week. Same old, Roscoe Brown 211, Colston lower level. That's where the events is happening this week. Go over there, get y'all free food, and all that go. All right. All right, so I can take it down? Good? All right.